This video will look at structured query language and transaction processing. So SQL, structured query language, made up of a selection of statements, and the purpose of the language is to carry out jobs on a database. So a few things that you might do: you might create a table, you might select data, you might update data, you might delete data, you might insert some data into the database, and we can do all of these things with these SQL statements. So let's have a look at creating a table. If we wanted to create this empty database table, we could use the following SQL syntax. Create table, capital letters, then we'd provide the name for our table, in this case it's students, and then in brackets we've got each of the fields that we want our table to have and each of the data types that those fields are going to store. Now, if we've got some data in a table and we want to select some data that we want to work on, we can use the select statement. So for example, if this was our database table and we use the following SQL statement, select first name from students, that would produce the following. It would select every bit of data in the field first name, or in the column first name, in that table called students. So in this case it would result in all of those first names that you can see on the slide. Here's a few more examples. Again, if that's our table, if we were to use the following statement, in fact example 2 should be focusing on now. If we did select first name, comma, surname from students, that would be able to select two fields, two columns from our database, so that we can just work with that data separately. We could use the wildcard as well. So select star, which means everything, select everything from students, and that would result in exactly what we saw originally. It would select all of the data in the table. Now the where clause is often used in conjunction with the select statement, and it's great when we want to sort of drill down and get specific data which might match a particular criteria. So here we've got a table, and let's say that we wanted to select all the rows in the table where the value in the field column matches 9AB. Okay, in the groups column, sorry, in the field groups matches 9AB. So if we went and did the following, select everything from students where group equals 9AB, that would highlight the following records. So it would get all of the data, but only where group is 9AB. So just those three records would be selected. Now the update statement can be used to update data after it's already been stored in a database. The where statement can set the particular record which is going to be updated. And if there's no value in the where statement, then all the records will be updated. So here we've got our table that we're going to be working on at the top, and underneath is where the result or will be the resulting table after the following statement is run. So here we're seeing we're going to update the table called students. We're going to set the surname to Goody where the first name is Tess. So in our original table we've got Tess Smith, and after we've run the SQL statement it's changed Smith to Goody, and it's only done that where the first name was Tess. If we didn't have that where clause, then all of those surnames would be updated. The insert statement is another SQL statement that you need to be aware of. So this allows us to insert new data into our database. So if we were to run the following SQL statement, insert into students, into the table called students, the values, and then separated by commas. We got each of the values that we want to place into our database. You can see that that new record has been added on at the end. So the SQL statement in this example inserts a new row into the table called students with the values specified in the brackets. They'll be entered in the order in which they're provided. Now the delete statement can be used to delete a record or a set of records. So here you can see that we've got delete from students where first name equals Jim. It finds the record where first name is Jim and it deletes it from the table. So the SQL in this example will delete the row or the rows. It's important to recognize that if you had more than one person called Jim, they would be deleted as well. In the table called students where the value in the field called first name matches Jim. The like statement. So the like statement is used with a where statement, and it's used in order to find patterns within the data in a column. So for example, it can be used along with a wildcard, so a percentage sign, to find all the names that start with a particular letter. So if that was our starting table and we wrote the SQL statement select everything from students where first name was like, and then we've got T, percentage sign, which is the wildcard. What it will do is it will select all the rows in the table where the field called first name starts with the letter T. So we use the like statement in this example to find all of the peoples with first names that begin with the letter T. The wildcard takes care of all of the other letters. As long as it starts with a T, it would pick it out. Now the join statement is used to select records in two separate tables that both have the same value. So here we've got a relational database. We've got our customers table, we've got our orders table, and we've got our products table. Now if we were to run the following code or following SQL statement, select orders order number. Now that means select the order number, the field order number from the orders table, and select customers.surname. So that means go into the customers table and select the surnames column from orders, so from here, because that's where we got the link, and it says join customers on orders.customerID equals customers.customerID. Now that means that we are to try and find where matches occur in the customer ID table here with the customer ID table in the customers table. So what it would do is it would result in the following output. So remember, we're selecting the orders number from the orders table and the surnames field from the customers table, and we're trying to match up where 1 equals 1, 2 equals 2, 3 equals 3, 4 equals 4, 5 equals 5, and so on. So what we've got here is, and sorry, 1 and 1 again, we can see how we're joining together where these foreign and primary keys match up to produce our result. So again, the join statement is used to select records in two separate tables that both have the same value. Customer ID has the same value in both of these tables, so it joins them up and matches them. So the SQL statement in this example will join the order number with the corresponding customer's surname. Now the drop statement. We've already seen how the delete statement will delete data from a database, but that doesn't actually delete the structure. So if you deleted everything in a database, the structure of that table would still remain. Now the drop statement is what we used if we want to remove the data and its contents. Sorry, the database data and its structure, I should say. So if we drop table students, that would produce nothing. In other words, it would be removed from existence. So that's just an example of a few SQL statements that you need to have an understanding for A level. Now we'll have a look at transaction processing. Now, whenever we do anything with a database, a single operation that we perform on a database is known as a transaction. Now, it says here, for example, a single operation carried out on a database booking system could be the booking of a hotel room, which cannot be complete until a payment has been made. So this transaction can therefore have more than one process. So a single operation, the booking of a hotel room, is a transaction, but a transaction could have more than one process. We need to make the booking, but only after the payment's confirmed. So it's therefore vital that transactions fully complete and cannot partially complete, because otherwise, in this example, a booking without a payment would not be very good for an organisation. So to ensure that a database processes transactions reliably and completely, it follows the ACID principles. So let's have a look at what these mean. So ACID stands for atomicity, consistency, isolation, and durability. So let's have a look at atomicity. What does this mean? So it's the requirement that a transaction must be fully processed or not processed at all, removing the possibility of a partially completed transaction. Consistency. The requirement that a transaction cannot compromise referential integrity. So we looked at this in the 2 lessons back when we looked at relational databases. But just to remind you, referential integrity is where if you've got a relational database, you've got data in 2 different tables that rely on each other. If you were to delete data in one of those tables, it would have to be a record that relied on it would have to be deleted in another, because there needs to be consistency throughout the table, throughout the database. So it says here, for example, consistency will ensure that an order cannot be placed by a customer who exists in the customer table for a product that does not exist in the products table. In the same way, consistency would ensure that a product cannot be deleted from the products table if it already exists in a previous order. So if you can't quite remember about referential integrity, have a look at the relational database video. But ultimately, it's about that idea that if you've got data that relies on data elsewhere in the database, on a different table, that link has got to persist. It needs to have consistency. Isolation. The requirement that a transaction is performed in isolation so that no other process can interfere until the transaction is completed. So to facilitate this, whilst the transaction is operating on a record, the record is locked, stopping anybody else or any other thing trying to write to that record until the transaction's been completed and committed to memory. And durability. The requirement that once a transaction is completed, the database change is immediately written to secondary storage so that the transaction cannot be lost in the event of systems failure or power cut. So the ACID principles, atomicity, consistency, isolation, durability, that all ensure that transactions are fully committed and not partially committed. That things are done consistently across, that they're done on their own without any interference, and that they are, as I said before, committed to secondary storage. Let's have a look at record locking very quickly. So there could be a situation where a record is accessed and edited by 2 or more different users at the same time, which can cause issues. So you could have, for example, for a given customer record, if a database user altered the customer's surname and another altered the customer's address and both saved their change at the same time, what changes are going to actually persist? Well, the likelihood is that one of the changes would not be made. Inconsistencies would therefore be likely. So we looked at consistency being a really important principle when we're dealing with transactions. We need to therefore ensure consistency, and to make sure that happens, we do record locking. So record locking ensures that the issues outlined above don't happen. Record locking is the process by which a record is locked the moment a user retrieves the record, so that no other user can access the record whilst it's being edited or updated. The moment that transaction is completed, The record is then unlocked for others to access.